Today I'm going to be teaching you guys how to calculate the value of a resistor in a very easy way. First of all, we need to know that a resistor is that component that is used to reduce the current that flows in a circuit, and it has circuit diagram. This is it, and the real life diagram is somewhat like this, like this, and we have some colors on it, okay, and then yes, just about like this. Before we continue, there are some ways these colors are now used to get the actual value of a resistor. How do we do that? Before we talk anything about that, we have to first of all go to the color codings of the resistor. Okay, so we have a famous rhyme that we use to remember this. I just put this one together. So please just listen. This is black. It's just like a story. Boys rape our yellow girls, but Veronica gives willingly. Okay, now this is how it is. All right, so let's talk about what each of these words stands for. So the black is the black in color, boys is brown, rape is red, and our orange, and yellow is yellow, girls is green, but becomes blue, Veronica is violet, gives is gray, and white willingly is white. Okay, now dividing it again, we get to see that the black is the 0 in resistor. We don't start counting from 1. Black is 0 and brown is 1, red is 2, orange is 3, yellow 4, and green is 5, blue is 6, violet is 7, gray is 8, and white is just faithfully 9. All right, so this is the color. So we can now easily stroke this one out. Now we see that we have the actual color here. That rhyme is just for you to remember it, okay? So now we see that the colors are now rhyming with the numbers that they are, okay? So the calculation, how to do it. First, before we continue with this, we have to give you some laws, all right? Some things that you shouldn't forget. First of all these things is that resistors, there are colors in them, and the colors in a resistor is not more than 5. It is not less than 3. So the maximum colors we can get in a resistor is 5. The least color we can get in a resistor is 3. And then these resistors has what we call tolerance colors. Apart from these normal colors we have, it's just 2. The gold and the silver, okay, they are called the tolerance color, T. All right, so tolerance colors excuse me please. Tolerance colors are these colors we use to know where this color starts from and where it ends, and the tolerance of that particular resistor. All right, so let's say for example we have a resistor that has 4 colors on it. So the first one, let's say brown, second black, the third red, and then the fourth is gold. Don't forget that gold will always come with all resistors. I mean, not gold, like tolerance color will always come with all resistors. All resistors must have a tolerance color, at least 1 or 2. So now this is how it is. This tolerance color is what we use to know the last part of a resistor. As it is now, our first color is the brown, not the gold. Resistor do not have polarity. That means it doesn't have a special way you can connect it in a circuit, which means that determining where the color starts, the head or the tail, it's going to be difficult if the tolerance color were not there. But the tolerance color, if it is there, is going to show us the part which is the last part. Okay, so as gold is here, we have the brown as 1, black as 2, and red as 3 in the color setting. Okay, that's that for that. Another thing we need to know is that we have to calculate using the first 3 colors. When we say first 3 colors, now we are talking about counting from the front, and the front is the side where the tolerance color is not in. Okay, so counting from the front, we get to see that we have brown, black, and red as the first 3 colors. So these are the only 3 colors we are considering. We will not consider the gold. Okay, next, tolerance color can never be the second color of a resistor. Okay, let's say for example we have gold at this point, and here we have red at this point. Okay, so the side which is the last part of it, let's say the tail of the resistor, is this side where the red is. Why? Because tolerance color cannot be the second color of a resistor. It can only be the third color of a resistor. Okay, now that's that for that. Another thing we need to know is, while calculating the resistor, we will have to put down the first 2 colors the way they are, and then the third color we have to convert it into its corresponding number of zeros. Let me explain. So imagine we come and put something like red or orange. Okay, orange in the third color, and this one silver as the tolerance color. Okay, so we said put down the first 2 colors the way they are. It means brown. What's the brown? What's the number of brown? Brown is number 1, so we'll put it 1 the way it is. Black. What's black again? 0. Okay, so we'll put down black the way it is. Now we have 10. Now this is orange. Remember, it says convert the third color into its corresponding number of zeros. Okay, so this is 3. Orange is 3, so we just say 0, 0, 0. Okay, this is the orange, but we've converted it into its corresponding number of zeros. So what we have as our final answer becomes 10,000. 10,000 ohms. Okay, resistor is measured in ohms, so whatever it is you are calculating ends in ohms. Now we need to convert it into kilo ohms if we must buy it in the market. Most of these sellers of components, when you tell them you want to buy 10,000 ohms, my brother, they will tell you they don't have it because they don't know. Okay, but when you tell them you need to buy 10 kilo ohms, they will tell you how many pieces do you need. So, but what you need to do is to just divide this by 1,000 in order for you to convert it into kilo ohms. So we have 10 kilo ohms as your final answer. There's something else we need to know about these resistors. You see, when black ends a resistor, let's say we have brown, black, and black. Okay, if black ends a resistor, this is what you do. Remember, we said put down the first 2 colors the way they are, and then convert the third color into its corresponding number of zeros. This is the first color, brown. We'll put it down. Black is 0, putting it down the way it is. And then the last one is also black, but this time there is a law governing it. Convert it into its corresponding number of zeros. When we come to the table, black is 0. Now they said convert 0 into its corresponding number of zeros. It means that there is no 0 there. So your final answer is now 10. 10 what? 10 ohms. Okay, so that's how it is. So whenever black ends the third color, when black appears at the third color, what do? Just throw it away. Don't consider it. Now we've talked about black. Next we need to talk about is tolerance color. When tolerance color ends up at the last the last color of the first 3 colors, which means the third color. Okay, when we have something like gold here. Okay, now this gold is among the first 3 colors. We need to consider it because it's among the first 3 colors. Let's say we have gold. Let's say we have gold here, and we have silver here. Please, I need to tell you about the fact that gold is considered as 5% tolerance in resistor, while silver is considered as 10% tolerance. Okay, so if we have this here, we still need to follow the first the law saying put down the first two colors the way they are. The first two colors are the brown. The brown is what? 1, and we'll still put it down. The black is what? 0. We'll still put it down. Then this is good. Okay. In tolerance color, when it ends the first 3 colors, it has a slightly different arrangement. We don't convert this into its corresponding number of zeros. What do? We just write it down the way it is. Multiply the first 2 colors, the number of the first 2 colors, and then by the percentage of this guy here. So we have 5%. 5 all over 100. Of course, we know anything percentage has to be all over 100. When we say 10%, we mean 10 over 100. 50% means 50 over 100. 100% means 100 over 100. All right. So now we have 10 times 5 all over 100. So what do we have here? We have 50 divided by 100. And this is definitely 10 over 5 over 2. 5 over 10. So this is 0.5. So this is 0.5 ohms. So when we have color code saying brown, black, and gold, we have 0.5 ohms. That's what we have. Let's go with the silver. Let's do the same with the silver. So let's say that we have a silver here, possibly silver, or silver gold, but we will not consider this guy here because it's the 4th color. We don't want to consider it because the law says consider the first 3 colors. Okay, the brown is 1, the black is 0, the silver is 10%. 10%, we just multiply those number of the first 2 colors by the percentage of this guy here. We have 10 divided by 100. So now what we have is 100 divided by 100. So what do we have? We have 1 ohm. Okay, so this is the value of this resistor. Brown, black, and silver is 1 ohm. With these guys, I believe we can be able to calculate any resistor. One more thing. You see, these last colors of these resistors, most times they are tolerance colors. Although we don't consider them in the calculation of resistor, they still signify something. Those things are telling us the tolerance of this resistor. Possibly, you see, these resistors are rated, like this one is rated 1 ohm, okay? But this silver here is telling us that this 1 ohm may not actually be exactly 1 ohm. It may be plus or minus 10% of 1 ohms. All right. So what it's trying to tell us is that when we measure this with our multimeter, we may not exactly get 1 ohm. We may get 1 ohm plus 10% of 1 ohm, or 1 ohm minus 10% of 1 ohms. Let's see. 10% of 1 ohm is what? That is 10 divided by 100 times 1. So 10 times 100 is still 10 divided by 100. So 10 divided by 100 is 0.1. All right. So this should be either, when you read it on your multimeter, what this guy is trying to tell us that this 0.1 is plus or minus 0.1. So it means if you read this with your multimeter, this resistor with your multimeter, I mean this resistor now that has 2 terminals like this. If you read it with your multimeter, you may be getting 0.9 or 1.1. All right. After all, 0.1 plus 1 is equals to 1.1. But let's do this again. 1 plus 0.1 is equals to 1.1, and 1 minus 0.1 is equals to 0.9. So when you read your resistor on your multimeter, it's going to give you either 1.1 or 0.9. This is the tolerance, the inaccuracy of this particular resistors. Well done. Okay, that's all for today. Thank you. My name is Joshua from Jonitech Electronics. It's nice to speak with you guys today.